Okay, today is called Applied Quadratics. Applications of quadratics is what I was going to say. And this is where, like, you have a picture and you're supposed to use math to solve a real world problem. Let's imagine for a moment that this is the graph of a submarine's depth. And at that moment it hit the lowest possible and then it goes back up again. My brother was on a submarine back between World War II and the present date. So he wasn't in during World War II. He's too young for that. But when he was on the submarine, when it would go down and they do a depth check, they had to be able to go deep with the submarine at any moment. And so that was the scariest thing, he said. And they would go super deep, and all of a sudden the submarine, like, think about it, the floor here never changes, right? All of a sudden it would tilt, like super tilty, because it's heading down deep. And when they would get to their given depth, the one we're going to stop at, he never had a problem. But there were some submarines that every now and then would reach that depth and they would have issues. And if you're really super deep and all of a sudden things start going wrong, it can go bad really quick because you're down super deep where there's a lot of pressure. And all of a sudden the hull can start to crack. You can have leaks in the submarine. So it was always a scary time when they went to do their depth check. But if you're a submarine, you have to be able to go deep, and they have to know that they can do it at a moment's notice. So anyway, what's the deepest this submarine went? Well, it's that low spot. So let's figure out where it is. So everybody that's got that on your calculator, 3x squared plus 3x minus 7. I'm going to get that in here too. I changed mine to something else, but let me get it to plus 7 like you. Plus 7, and get rid of that last number. Graph. If I want to find that low spot, minus 7. My bad. Okay, I gotta go over here and put a minus in there. Minus 7. Okay. If I want to find that low spot, there's an official name for a low spot. What's it called? A minimum. Everybody go to second calculate, and minimum is the third choice. Second calculate minimum. Now, pay attention, because this is the part where a lot of people will mess up. Second calculate minimum. The first thing that happens is a question. Do you see at the bottom of your calculator where it says left bound question mark? I wish it just jumped right to the low spot. It does not. It asks you to say set a left boundary. The left side of this minimum is here. You can be anywhere to the left. There, I'm to the left of it. I hit enter. Now mine puts in this little neato line. Yours probably doesn't. Most calculators don't have that neato line. They'll have this little caret thingy right here that says you just set the left boundary. Now it says right bound. That means we go to the right of it. Hit arrow, 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 and hit enter. And last is guess. That means guess where the low spot is. I get right on top of it, in my opinion. I think that's as low as I can get, and then I hit enter. And it jumps to the final answer, which is x equals negative 1.5 and y equals negative 9.25. Let's say this is in thousands of feet. Then that means that this submarine is down 9,250 feet. Do you get what happened there? Now, would you please look at your partner's calculator, and if they're like, I didn't get that, make sure they have the same thing as you do. If they need help, help them. Yes. Yep. It gets you to the exact right spot automatically. This is not something you can be close on. It'll tell you the right spot if you do it right. Now, one thing you mentioned that's kind of important. If the answer is almost off your screen, like all I'd have to do is move this up and my window, I might not be able to even see it anymore. Right now my y min is negative 20. What if I made my y min negative 10? That's the lowest y I can go to. I don't think I'll be able to see it when I hit graph. And if you can't see the low spot perfectly, oh, no, looks like I can still see it. But if you couldn't quite see it, then that means you can't find the low spot. You have to be able to visually see the spot that you need. So again, I'll just make one last tweak. I'll go and make it -9 instead of -10. And then I'll be able to just not quite see it. Please don't talk now. Thank you. All right. So if you can't see the spot you were trying to find, like now, I can't see the low spot. You'll never be able to find it with the calculator then. You can even do the process perfectly, and it won't tell you the low spot. Okay? So you got to be able to see it. All right. Now, everybody, let's change one little thing on the calculator. Throw a negative in front. Go second, insert a negative. The negative is right beneath the 3. Remember, a negative is different than a minus sign. And then hit graph. You'll see your parabola has flipped over. All right, now let's do one more little tweak. Instead of -7, let's make it end with a -2. (x² plus 3x minus 2). Now hit graph. Do you get I changed where its vertex is now? Now it's not a minimum, it's a maximum. All right, so everybody right now, go second, calculate maximum. See if you can follow those 3 things they want. They ask you 3 questions. Kind of like the Monty Python Bridge of Death. Ask of ye these questions 3. It says, first of all, left bound. The left bound, as long as you're to the left of it, you can hit enter. You don't have to be exactly anywhere, just left of it. Now I'm to the right of it, and I hit enter. Now I'm right on top of it, and I hit enter. And it jumps to the final answer, 1.5, 0.25. Any questions on that? Yes? Okay, that means that there's something wrong. Can you see the highest spot on your calculator? Can you see, when you look at the picture, can you see? Okay, then that means your window is messed up. Try Zoom 6.
No, it won't let me graph it at all.
Have you pressed Zoom 6 or not?
Yeah.
Okay, now try hitting graph.
You might be using the wrong name.
I understand. And we're going to try this first. Did that work or not? Okay, so then go to the y equals screen. Do you remember me saying to use the negative that's right underneath the 3? Did you by accident use the negative that looks like a minus sign? Okay, good. Thank you. Good tip. You're right. And I did warn them about that, but a lot of people missed that. So, okay. Now, that was the vertex. Let's move it up a little further, because for this next thing, we're going to need to have the graph be a little higher up. How can I make my graph go up higher? At the end here, the y-intercept, if I force the y-intercept to be higher, it'll make it go higher, right? Let's change it to +2. That forces this to have a y-intercept of 2. There we go. Okay, now, could we find the vertex again? Yeah, but that's just a minimum maximum thing. We've practiced it twice. By now, hopefully you've got that down. Now let's do something called finding the roots, the zeros, the x-intercepts. Do you get that they aren't crossing at really nice places? The answer is not like 2. The answer looks to me like it's about 3.5-ish, but I'm not sure. And there's another x-intercept at like -1 maybe, or -0.5, I'm not quite sure. So how do I find those? Second, calculate the zeros. Okay, now let's do the one. Are you guys doing the one on the right or the one on the left? Raise your hand if you were heading towards the one on the left. Okay, we'll do the one on the left. It says left boundary. I got to get to the left of my zeros. By the way, there's 2 zeros. One's here, one's here. I'm doing the left one. So I want to get to the left of that. And every now and then I'll have kids say, but that's not to the left, it's underneath it. Yeah, but it's also to the left of it. Okay, I'm to the left of it now, so I'm going to hit enter. Now I go to the right of my 0, and I hit enter again. Now I've got it narrowed down to between these two caret marks. And it's saying, in between those two, sir? And you're saying, yes, and I believe the answer is right here. And you hit enter. And the answer is negative 0.56. I would like you to verify that the other person knows how to do this by seeing that answer of negative 0.56 on their screen. If they had issues, please help them. Okay, everybody find the other zero now, the other x-intercept. You have to answer the questions 3. Left boundary, right boundary, and then guess where it is. And then it should tell you, and then you compare with your partner. Make sure you get the second y-intercept, or sorry, x-intercept correct also. Yes? It was negative 0.56. If you're coming up with a different answer, you might want to double check that your original equation says negative x squared plus 3x minus 2. Make sure they know how to do this. They'll need it for their next test. Finding the zeros. Yes? Okay, if it says some number that's really close to 0, like e to the negative 0.7 or whatever, that means you're getting really, really close to 0, but not exactly 0. What she's saying is when she does it, let me do one, and maybe it'll pop up on this one. I go calculate 0, which is number 2, and I get to the left of it. I'm doing the right side one now. I am to the left of it, and then I get to the right of it. And then I get right on top of it. I'm guessing where it is. I think it's about there. I hit enter. And there it is, 3.56 and y equals 0. If this ever is a weird thing like 1.2 e negative 17, what that means is you have 1.2 and you move the decimal 17 spots to the left. And the point is it's really close to 0 if it's not 0. Do you get if the calculator can't get it 0, it's going to say an answer really, really close to 0 like this? And that's a teeny, 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 tiny number, and it's pretty much 0. I know that's frustrating because you think the calculator could be perfect. You know, they're machines. But it's trying to read its own graph, and sometimes it can't quite tell from exactly where it is on the graph that it's at 0. It thinks it's really close to 0. It's weird. I would love to someday talk to a TI expert who knows exactly what's happening there. I know some people do know, but I don't. Okay, you have found the zeros. You've also found the minimums or maximums. Let me show you where you'd use that in the real life. Let's say they give you an equation. It's like this, negative 4.9 t squared plus 6t minus, plus 3. That is an equation. And let's say I graph it, and it looks kind of like this. If they ask me for what's the highest the ball ever went, what are they really asking me for? The maximum or the vertex. But since our calculator doesn't have an option for vertex, it does have an option for maximum, I would go second, calculate the maximum. What if they said, when did the ball hit the ground? I hope you know that that would be this spot right here. That's when the ball hit the ground. People think it's where the ball hit the ground. It's when, because this is time and this is height. Logically, when the height gets to 0, see the height was up here at the highest moment. When the height gets to 0, the ball has hit the ground. And this is the time it took to get there. Okay? So if you find the 0, listen, if you find the 0, this spot's called the 0. If you find the 0, you're finding when the ball hit the ground. Okay, so those are the two main functions we learned today, which is find how high the ball went, find when the ball hit the ground. When I say how high did the ball go, that's code for finding maximum. When I say when did the ball hit the ground, that's code for finding 0. Okay? All right. So now, let's actually do some of your homework problems together. It looks like, I'll pause for a second while I find it. Since we don't have much time left in our lesson, because we went over a lot of test questions and stuff, I'm going to assign a shorter assignment on this. You may skip problem 4, and you may stop after problem 7. So in other words, skip everything after problem 7, like 8, 9, 10, etc. Stop? No. I said skip problem 4 and skip everything after problem 7. All right, so number 1, it does say round all answers to 2 decimal places. That right away makes me think you're probably using the calculator. Besides, this would be really hard to find the vertex. No, wait, it wouldn't be that hard. I just have to complete the square. But we're doing with the calculator now. You have a whole new way you can do it. So everybody put that equation in. X squared plus 5x minus 3. X squared plus 5x minus 3. And graph it. And this time, I can't quite see the low spot. So I'm going to have to change my window. I was playing around with my window before. Now I got to pay the price. My y min, the lowest my y can go, needs to go further down. Negative, let's say 20. And now I got to be able to see that low spot, or I won't be able to find the minimum. Now I can see it. Second, calculate the vertex, which is a minimum in this case. And I go to the left of it. And once I get to the left of it, I set that as my left boundary. Enter. I go to the right of it. And I hit enter. And then I go, guess where it is. I think it's about right there. And I hit enter. And it says I was close to right. The minimum is at. And therefore the vertex is at negative 2 point. Do you think it's really 4999, or should I just round it to 2.5? I would go with 2.5. Negative 2.5. And the y is negative 9.25. If in the context of a real-world question they had said, what's the lowest that the submarine went? You would say that the answer is the y. Y controls rise and fall. So the y is the lowest it went. The y of negative 9.25, maybe it's in thousands of feet like we were talking before, negative 9,250 feet, as in below the surface of the ocean. That would be really, really deep, by the way. That's almost 2 miles deep. And there are things that can go deep, but we don't really, that's one of the great unexplored places on the earth, is the places that are super deep in the ocean. Because we've been almost everywhere else, right? Been on top of the mountains, we've been in the jungles, we've been all over the place, but no human has ever been miles deep in the ocean. I shouldn't say that. It's probably miles. Is probably, maybe somebody's been 2 miles deep or something, but in a submarine. But there are places that we haven't been that are like deepest spots in the earth. Nobody's ever seen it. We just have to guess what's down there. There's beasts down there that are pretty amazing, like the giant squids, insanely big, and they live super deep down there. Only recently we've seen glimpses, because they got cameras that can handle it now, that they've gone down there and taken pictures of these insanely big animals, fish, whatever they are. I don't know what a squid is. All right, beast, it's probably safe to say. All right, so what's the other question on this one? The other question says, what are the X-intercepts? Oh, that's also known as the zeros. So I can go second, calculate the zeros. Okay, so we are calculating the zeros this time, so I'm hitting enter, and I'm going to go to the left of the 0. And that's good enough, and then get to the right of the 0. And then guess exactly where the 0 is. And then there it is, negative 5.54. And, ooh, I got one of those weird ones. 1e negative 12. That means a 1 with the decimal moved over 12 spots to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. Do you get how that's pretty much 0? Okay. it's infinitely close to 0, and therefore, actually it's not infinitely, but it's really, really close to 0. So that pretty much means y is 0, and therefore it is a 0. It's one of my roots. All right. Remember not to have bald answers. So when it wants the x-intercepts, that's where y is 0, right? So put something comma 0. And the vertex is a point, something comma something. Okay, remember I said you could skip problem 4 and that you could skip 8, 9, and 10. That makes it, and 11, okay. That makes it definitely a doable size assignment. And that's all I've got for you for today.